All right, I'm going to do a few examples of some of the homework practice questions in the textbook. This is number 5F from section 4.4. All right, so if we work from the inside out, we want to apply this exponent first. So using the power of a power rule, we multiply the exponents here. So 3 times -1, that'll give us x to the exponent -3. And here there's that exponent of 1. So 1 times -1 is going to be y to the -1. Okay. This bracket here doesn't have an exponent applied to the outside of it, so it's going to be left right now as x to the exponent 4 times y cubed. Okay, all of that is over. Here we can apply the power of a power rule as well. So multiply these exponents, we get x to the exponent -4, and the exponent -3 is multiplied by -2, and we get y to the exponent 6. Remember, all of this is still to the exponent of -1 here. Okay. We can simplify farther because now we see in the numerator we've got this power that has a base of x and this power that has a base of x that are being multiplied together. So same base, we're going to add the exponents because we're multiplying the powers. So -3 plus 4 is 1. Okay, we've also got this power and this power that have the same base of y. So same thing, we're going to add the exponents because we're multiplying. So -1 plus 3 is 2. Right, so that's over x to the exponent -4 times y to the exponent 6, and all of that is still to the exponent of -1. Okay. Now we can divide powers that have the same base. We can apply that exponent law. So here we've got two powers with the same base of x. So we're going to subtract the exponents. 1 minus -4 is 5. And here we've got two powers with the same base, base is y. And so again, we're going to subtract the exponents because we're dividing those powers. So 2 minus 6 is -4. And all of that is still to this exponent of -1. So we know how, well, here we can actually apply the power of a power rule again before we simplify what's in the brackets with that negative exponent. So here, using the power of a power rule, we've got a base x, and we're going to multiply 5 times -1, so -5. And here we've got a base y, power of a power, we multiply these two exponents to get +4. Okay. A negative exponent means we're going to take the reciprocal of the base. So the base here is x over 1. And the reciprocal of that is 1 over x. 1 over x to the exponent 5 times y to the exponent 4. Okay. 1 to any exponent is just 1. So in the numerator, there will be a 1, y to the 4. In the denominator will be an x to the 5. So this is our simplified form of this expression. All right, here's number 9a from the same section of the textbook. The first thing we want to do here probably is rewrite these decimal exponents as fractions because then we can possibly convert them to radicals if we need to at some point. But it's probably better to look at those exponents as fractions. So let's start by doing that. So we'll keep everything else the same and just change this to a fraction. So 0.5 is going to be 1/2. And 0.25 we know is equal to 1/4. Okay. Now we can apply those exponents to what's inside the brackets using the power of a power rule. So here 36 to the exponent 1/2, m to the exponent 4 to the exponent 1/2, and n to the exponent 6 to the exponent 1/2. Okay. So we'll apply those power of a power steps in the next line. Times 81 to the exponent 1/4, m to the exponent 12 to the exponent 1/4, times n to the exponent 8 to the exponent a quarter. Okay. 36 to the exponent a half, we know is the same thing as saying the square root of 36. Okay, here, the power of a power rule, we multiply the exponents. 4 times 1/2, so we get an exponent of 2. Okay, same thing here, multiply the exponent. 6 times a half is 3. The 81 to the exponent of 1/4, we know can be rewritten as the 4th root of 81. Okay, here, power of a power, we multiply the exponents. 12 times a quarter is 3. And here, same thing, multiply the exponents. 8 times a quarter is 2. So we can take the square root of 36. We know that's 6. And the 4th root of 81, we know is 3. Okay. 6 times 3 is 18. Right here, we can multiply m squared times m cubed. So we're multiplying two powers with the same base. We add the exponents. We get an exponent of 5. And using the same exponent law, we can multiply n cubed times n squared. So again, we're multiplying two powers with the same base. We add the exponents, and this will be our simplified answer. All right, here's the solution for number 15 from section 4.4. What's important to note, first of all, is that this restriction that's stated here is just simply a restriction that's meant to ensure that we're never taking the square root of a negative number. So that's the purpose of that restriction there. What we want to focus on is simplifying this expression. What might be helpful, first of all, since we see that some of this is written using radical symbols and some is written using exponents, it might be helpful to rewrite all in the same form. So let's rewrite this all in exponent form. We know that this radical symbol, this is square root symbol, that's the same thing as using an exponent of a half. So we've got this whole piece here that is all to the exponent of 1/2. And in the denominator, we've got a cubed root, and we know that that's the same thing as using an exponent of 1/3. So we've got x to the exponent 3n, and that is to the exponent of 1/3. Okay, so now it's all in exponent form, and we can use exponent laws in order to simplify. Okay, so here we've got two powers that have the same base. Okay, this x, keep in mind, has an exponent of 1. We've got two powers with the same base, so that means that we're going to add the exponents because we're multiplying. So we're going to add 1 plus 2n plus 1. Okay. Remember, all of that in the numerator is to the exponent of 1/2. Okay. Here, we've got the power of a power, so we're going to multiply these exponents. So we've got x to the exponent 3n times 1/3. Okay. 3 divided by 3 is 1, and so we're left with an exponent of just n. Okay. In the numerator, we can simplify this inside the brackets a little bit because we can combine like terms. So we get an exponent of 2n plus 2. Okay, still all to the exponent 1/2. Okay. Now if we apply this exponent of 1/2, that means we're going to multiply these two exponents because it's the power of a power rule. So x to the exponent of 1/2 times 2n plus 2. Okay. And so that means we get, so 1/2 times 2n is n, and 1/2 times 2 is 1. Okay. And here we've got two powers that are being divided, and they have the same base, so we can subtract the exponents. So n plus 1 minus n. Okay. And so n minus n is 0, and so in fact we end up with just x to the exponent 1, or x. All of this simplifies to just x. Keep in mind that we did have the restriction x is greater than 0 in order to make sure that we're not taking a square root of a negative number. And so this x value here that we get at the end would only be for x values greater than 0.